hello guys, I am Tarun. In this video, we will discuss in detail about information gain algorithm. Information gain algorithm are widely used in decision trees. It is a very popular algorithm and it proves to be very useful. Now let us look at information gain algorithm in detail. So basically, the decision tree uses two algorithms, Gini index and information gain algorithm. So if you look at the construction of the decision tree contains three parts: internal node, leaf node, root node. Root node at the top level and leaf node at the bottom level. Internal node occupies the mid position. So each internal node undergoes recursive splitting and it represents the outcome of the test performed on the previous node. So this decision tree depends upon the recursive splitting of nodes. And for the decision tree to be very efficient, the splitting process should be very efficient. So for the splitting process to be very efficient, we should choose that particular attribute such that it would be able to split the data very efficiently, so that test condition can be performed and the results are very accurate. So it is very important for us to choose the attribute which will best split or classify the data. So to accomplish this purpose, information gain is used. It will choose the best attribute which will best split the data items so that the test condition can be performed on the attribute. So how it does is, it's basically like calculating a standard deviation of a set of values. We'll find the average value and we'll calculate how far is one particular value from the mean value. So this is the outline of decision tree algorithm. Now let us go deep into it. And this is a very popular and very useful algorithm. So let us take an example to understand it better. We have three attributes x, y, z, and we have two class labels 1 and 2. All these are distributed within these two classes. Now the major question arises is that how would you distinguish class 1 from class 2? So for this, information gain algorithm is used. Now let us see this example. So basically there are two class labels. Now we should find the attribute which will best split the data items and classify it. So here we can use the hit and trial approach to find out which attribute is the best. So let us take the attribute x. So based on x, we can split the data into two kinds. The part where x is equal to 0, the part where x is equal to 1. So the part where x is equal to 1, we can clearly see from the table that when x is equal to 1, class 1 is also satisfying, class 2 is also satisfying, and two class 1s are satisfying and one class 2 is satisfying. And when x is equal to 0, only class 2 is satisfying. So it splits into two parts. Now we'll find out the information that can be achieved from this attribute. It's basically like calculating a probability. Say if you want to calculate the probability of head when getting head when a coin is tossed, we'll calculate the probability as 1 by 2. That is the number of favorable outcomes by the number of elements in sample space. It's just like that. So first we are, and it works on a formula, that is yi by yi plus n into log of yi by yi plus n minus yj by yj plus n log yj by yj plus n, where yi and yj are unique elements in a data set. So first we'll calculate for the first set there are two class labels 1 and 2. So we are calculating first 2. So our yi is 1 because there is only one class 2 label in the first data item. So minus 1 by 3 is the sample space, and log of 1 by 3 to the base 2. So we have calculated the probability distribution for class 2 in first data part, and similarly for class 1 in first data part. So two 1s are there, so two favorable outcomes. So minus 2 by 3 log 2 by 3 to the base 2. So this is the formula. So we have all the values. So we will calculate the value as 0.9184. Now for the second data part, there is only one class 2. So the probability is 1. It's a sure event. So according to the formula, yi by yi plus n log yi by yi plus n minus yj by yj plus n log yj by yj plus n, yj and yj plus n are same. So log of yj by yj plus 1 is log of 1, that is 0. So the information cannot be gained and it is 0. So now we will do exactly the same we will do in the lab experiments, that is calculating the standard deviation kind of thing. So gain, that is how much information can be gained from this attribute x alone, that is 1. The information that can be gained from the parent data, that is this data, is always 1. We can gain some information, and from the child how much information can be gained is that's what we calculated here. So 1 minus 3 by 4 into 0.9184 minus 1 by 4 into 0 equal to 0.3112. 0.3112. This 0.3112 is less than 0.5. That means you can gain some information from it, but not that extent, not that efficient information gain can be possible from splitting on the basis of attribute x. Now we have calculated for x. Now let us calculate for y. And for the first step we have calculated this 3 by 4 and 1 by 4. This 3 by 4 comes from here. How many x is there? 3. And how many data sets are there? 4. So 3 by 4 into 0.9184. And 1 by 4 is when x is equal to 0. X is equal to 0, the probability is 1 by 4. X is equal to 1, the probability is 3 by 4. So we will calculate 3 by 4 into 1 by 4. And similarly, like x, we will do it for y also. For y, again the same kind, same base of splitting. When y equal to 1, y equal to 0. When y equal to 1, you will have two data items of the same class label 1. And when y equal to 0, you will have the same two class labels of type 2. So here when you do log I, only one class label is there. So it is a sure event. So probability will be 1. And when you take this log yi by yi plus n, it will be log of 1, that is 0. So information is 0. And similarly for y equal to 0, information is 0. So both of these information is 0. So even if this information is 0, it is just the information that the child is giving. Yeah, but the amount of information the child takes from the parent is what we are requiring. The amount of information that the child obtains from the parent is what is necessary. So that we will achieve by calculating this formula. So 1, that is the information that can be gained from the parent is always 1, 100%. So 1 minus, when y is 1, there is 2 by 4. So 1 by 2 into 0. When minus, when y is 0, again 2 by 4. That is 1 by 2. So 1 by 2 into 0. So 1 minus 0 is 1. So what it says is that this child parts can exactly gather the information from the parent and can deliver it. So the information that can be gained by taking the splitting attribute as y is 100%, the best one that can be selected. And similarly when you calculate on z, again when z is equal to 1 and z is equal to 0. So here basically if you see, when z is equal to 1, first data part contains one class 1 item and one class 2 item. Similarly when z is equal to 0, one class 1 item, one class 2 item. So when you proceed according to this formula, you will get the information of this data part 1 is 1 and this data part 2 is 1. So now we should find out how much information that this child part is obtaining from the parent data. So that is 1 minus z is 0 for 2 times, so 2 by 4, 1 by 2 into 1 minus 1 by 2 into 1 equal to 0. That is the amount of information that this child part obtains from the parent part is null. That is, there is no information gain in this case if you take the splitting attribute of z. It just exactly it is just exactly taking the data from parent, but it's not giving any additional information. So there is no gain, and this will have the least priority to be selected as the splitting attribute. So observations: the attribute x splits the entire data, but not that much efficiently as it is evident from the gain value. and moderate information can only be gained from that particular attribute x. The attribute y splits the entire data very efficiently into two parts, as is evident from the calculated gain value. I amount of information can be gained from the attribute y. The attribute z splits the entire data very inefficiently, as it is evident from the very low gain value, that is null. Very low information can be gained from attribute z. Very low or null information can be gained from attribute z. Hence, this information gain algorithm will choose the attribute y as the best attribute from which recursive splitting can be performed. So when you these are all is just for understanding. So basically, what is the mathematical expression or the formal definition of information gain is, it is also called as Kullback-Leibler divergence. That is the amount of information gained about a random variable or signal from observing another random variable. Same as like our attributes and class types. However, in the context of decision trees, the term is sometimes used synonymously with mutual information. So basically, it says that it is similar to probability distribution. So basically, we have done in 12th class, like we'll take a random variable and we'll find out the probability distribution. It is just same as the divergence, like how much far is that particular value from the other values. So this is the actual mathematical formula which comprises of the probability distribution of x from favorable outcome a divided by probability distribution of x from the sample space. So this is the formal definition of information gain, and hope you have gained some information about information gain algorithm. Thank you for this opportunity. Thank you.